PHAs are interesting for two reasons. First of all, they are bio-based and biodegradable. So from an environmental perspective, they are excellent. They also have characteristics which make them suitable replacements for up to 70% of all fossil-based plastics. And this combination, of course, is very interesting, both from a sustainability and a commercial perspective. And this is how PHAs are produced. You start with any kind of organic material, as mentioned, and here I've used molasses, which is a co-product from the sugar industry. And based on this carbon source, you grow bacteria. And after a certain amount of time, you cut the access to nitrogen. And then the bacteria can't grow anymore. And what they instead start to do is that they start accumulating the carbon in the surroundings in the form of polymers intercellularly. This is not conceptually, at least not very unsimilar to how we humans store fat as an energy reserve for the future. So what you have after this step is bacteria filled with plastics. And we are not only one who can do this process, there are a number of other companies who can do it as well, but where they struggle is how to get the plastics out of the bacteria, because of course you need to do that in order to use it for something useful. And what they do is they do a combination of solvents or chemicals, heat and pressure to disrupt the cell walls and to release the PHA. What we instead do is that we add another bacteria. We can call it the Bioextrax bacteria. And what the Bioextrax bacteria does is that when it comes into contact with the PHA-producing bacteria, it releases a cocktail of enzymes that breaks down the cell walls of the PHA-producing bacteria. And out of this, we get two products. We get the PHA, the bioplastic, which is released, and we get the co-product in the form of a hydrolyzed single-cell protein. This is the broken down cell walls of the PHA-producing bacteria. And it's important because only around, or never more than 90%, but often between 50 and 70% of the total output from the process is PHA, which means that the rest is the co-product, and you want to use it for something useful. And as it's made up of 50 to 60% of protein, which means that it's good for feed, you don't want to ruin it by using chemicals in the extraction. So our competitive advantage compared to other methods for producing PHA is mainly the cost, and this is mainly thanks to the co-product that we produce, but we also have lower amounts of energy, or we use lower amounts of energy and no chemicals. So it's cheaper from that perspective. It's also more environmentally friendly, again, because we use very little energy and no chemicals. And then we also produce PHA granules or plastics with a higher molecular weight. And that's important for certain applications. You open up new application areas, and it also makes the processing of the polymers easier. But what does the market for PHA look like? Well, currently it's still fairly small. Last year, around 550 million Swedish krona worth of PHA was sold in the world, according to Markets and Markets. But it's not PHA or the PHA market as it is, but the potential in the PHA market that is interesting, because it's generally considered the bioplastic with the highest commercial potential, amongst others by the European Bioplastic Association, and there are leading industry experts that mean that if we can cut the cost for producing PHA, we can increase the market by 40 times within a few years. And this market demand is primarily driven by new legislation. One such example is the EU's upcoming ban against added microplastics in a long range of products. And what's interesting from our perspective with that legislation is that it explicitly exempts PHA from the ban. And we saw a very strong reaction from a large number of large companies when this proposal was published, and we were contacted by companies looking for a solution. And this is why this graph produced by the Nova Institute in Germany is interesting. This is the total amount of plastic produced in the world every year during the last 70 years. we're producing around 350 million tons. And that equals a market of several thousand billions Swedish krona. That's a very large number. And we do, of course, understand that we can't replace all this plastic with PHA over the coming few years. But when we can get the production cost of PHAs down to a level that is similar to that of fossil-based plastics, which we believe that we can do, then something really big will happen very quickly. And this potential within PHA is something that we see in our everyday work at Bioextrax. We're working with companies along the value chain. We're working with companies who has the or who have the organic materials that we use for the production of PHA, but we also work with buyers of both products we get out of the process. So when it comes to the owners of the organic materials, we're currently doing pre-studies with 4 different companies, these carbon sources as we call them, and we're generally working with pretty big companies. The smallest we work with here has a yearly revenue of 15 billion Swedish krona. And we're also doing tests with 3 PHA current PHA producers, who are evaluating the possibility to use our methods instead of their current methods. When it comes to buyers of PHAs, we're also working with large companies. We're doing or planning trials together with companies who each are amongst the 3 biggest in the world in their respective market. And those markets are packaging, cosmetics, chemicals, FMCG, which is fast-moving consumer goods, and fashion as well. And then we're doing analysis of the co-product together with 1 European and 1 American feed producer. And on the patent side, we have received a notice of allowance for our patent in the US, and we expect a similar result within the EU soon.